All right, in this lesson, we're going to take a look at how to do a one-step conversion. And this can be kind of problematic sometimes, especially if it's units you're unfamiliar with. And I know many people have done this a lot of different ways. What I'd like you to know is I'm going to run you through a process, excuse me, that is something we're going to use all year long. And right now, it might feel unnecessary to a few of you because you could figure out how to do this right away. But we're going to set up a process of analyzing things that we're going to use with, say, chemical reactions and units that you've never heard of. And if you have a way of systematically approaching it, it sure makes it a lot easier. So we start with this problem right here. 50 gallons equals how many liters? Now, gallons to liters is not a normal conversion most people think of off the top of their head. It's not something you would have probably memorized. So what you're going to start with is looking for your resource page, okay? There's a conversion factor sheet that is in the resources listed on Schoology. Yeah, I would recommend printing that out and having a hard copy with you. If you take a look at this, it's got a whole lot of different sections, okay? And this is volume. So when you look at the volume section, what we're going to look for are these two units, and we're first going to determine, is there a nice one-step calculation that will get us there? Okay, and when I find these here, I notice that it says 1 gallon equals 3.78 liters. So I'm just going to write that down. 1 gallon equals 3.78 liters. And now when I can find a number that basically will get me from gallons to liters directly, that means it's a one-step process. And I know many of you right now could grab a calculator, punch this in, and you would know what to do. But I'm going to show you the process we're going to use, and I'd like you to set this process up so that we can use it with things that take 3 or 4 steps and all involve chemical reactions, okay? It's something that we'll use in tougher problems. So right now we're just kind of getting used to how to set it up. So the way I set these up is I take my first measurement, 50 gallons, and I write down 50 gallons. I don't make any changes. And I'm going to put a little fraction bar here, okay? And since this is a one-step conversion, since there's only one number that I have to deal with to get from gallons to liters, I'm going to put in one divider right here. Represents one step. Now, a divider is just for organizing things. You can pretty much ignore it. Don't worry too much about it. It's just to kind of help keep track of what's there. Now, the way I do this is I take the top of this fraction bar, and it's going to have the pathway. It's going to have what units I have and what I want to get to. I have gallons. I would like to get to liters. So I'm going to put liters on top in the next step. I have gallons, and I want to change it to liters. Now, on the bottom goes everything I want to get rid of. I don't want gallons to be around anymore. I want it to end up in liters, so I want gallons to cancel out. So whatever units are right here, I take them diagonally down, and I put them on the bottom right here. And if I look at this as one giant fraction, I have gallons on the top and gallons on the bottom. And when you take gallons divided by gallons, they cancel out and it becomes a value of 1. And that leaves me just with liters. Whatever units are left on the top, up here, is what my answer, whatever my calculation is, that's what it will represent. That's what my answer will be in. Notice I put no numbers, and there's a reason for that. I want you to always look at the pathway that the units must take, and then we worry about the numbers at the very end. This problem is essentially done. I have made all the decisions I need to make. I just need to put in some equivalent values now. So I look back up here on my sheet. Okay, in this case, this isn't something I made up. I got it from that resource page, from that conversion factor sheet. It says 1 gallon equals 3.78 liters. These numbers need to match those units. 1 means go where gallons is. Here's gallons on the bottom, so I'm going to put a 1 right there. 3.78 goes with liters. That's on the top, so I put 3.78 with the liters. 3.78 liters, 1 gallon. These numbers are equivalent values right here. They mean the same amount of stuff, just in different units for the measurement. Okay, now the way I solve this is I grab a calculator, and I'm going to multiply everything on top, and I'm going to divide by everything that's on the bottom. Okay, just like I would with a big fraction. Okay, but in this case, I got a 1 on the bottom. So this would look like this. I'd have 50 times 3.78, all divided by 1. But you guys know that if you divide by 1, it really doesn't change anything. So anywhere there's a 1, I can kind of ignore it. I don't really have to do much with it. So I'm really going to take 50 times 3.78. Okay, so if I do that, and I take 50 times 3.78, I end up with 189. Now the big question is, 189 what? We don't want to put numbers, we put what the numbers mean. There has to be a meaning here. And whatever I'm left with at the end of this calculation that hasn't canceled out, that's what this represents. This represents 189 liters. It means 189 liters would be equivalent to 50 gallons. Now I know most of you could probably grab a calculator and figure out to multiply these without setting up all the work. However, eventually we'll be dealing with things like kilojoules and moles. We'll be relating them in chemical reactions, and there's things you aren't familiar with, and there's several steps to it. So I want to get used to this process. So I'm going to ask you to show this on each one of your problems on your homework. Make sure that you show that process so that I can help work it out. It does you no good to put in numbers without units there. The units are the map that shows us how to get there. Okay, so let's take a look at the problem right next to it and just see if we can kind of apply the same principles, even though it might look just a little bit different. All right, so I'm going to look for centimeters and inches on my conversion factor sheet, and there happens to be right over here a single conversion factor that gets me from inches to centimeters. It says 1 inch equals 2.54 centimeters. Now, don't just jump in and think it's going to be just like this problem. We need to see what the units tell us. So I'm going to approach this as though I don't really understand it, even though most of you understand centimeters and inches. Grab a little back there. So I'm going to start with 200, and that represents centimeters. So I put 200 centimeters on top of the fraction. I do a one-step conversion, and I want centimeters to turn into inches. So inches is going to go on top. Remember, that's where I put the pathway, what I'm trying to change. I want centimeters to go away, so I'm going to drag centimeters down to the bottom here. That way they'll cancel out. And now I'm looking for inches and centimeters, but I have to look for those numbers. Okay? Make sure you put them in the right spot, the right meaning. 1 goes with inches. In this case, inches is on top, so 1 goes on top where the inches is. 2.54 centimeters goes on the bottom because that's where the centimeters is. So the units tell you where those numbers go. If you don't write in the units, it's real easy to get mixed up and have things upside down, and it totally changes the meaning. Now, when I go to solve this one, just like the last one, in this case, my 1 happens to be on top. So this would be 200 times 1 divided by 2.54. Okay, well, I don't really need the 1. Multiplying by 1 doesn't really change anything, so I'm just going to kind of ignore it. And this is really 200 divided by 2.54. And when I do that, I get a value of 78.7. And what does that mean? Here's the biggest thing. What am I dealing with? Centimeters has gone away. I'm dealing with inches. This represents inches. And what you can see here is just a process of going about one-step conversions. Sometimes if it's centimeters to inches, many of you will know how to do that already. But if you will set up these units, then when I throw in kilojoules or I throw in moles or grams, all of a sudden you have a way of approaching it, even if you don't really understand, like have a good concept of what that measurement represents. Okay, so this is one-step conversions. Please show this on your homework. Okay, I will give you the answers at some point for this homework, so to make sure that you understand, you can check and see if you're doing them right. But I want to see this part right here. That's how I know what you're setting up and you understand the process behind it.